What's up? It's your man, Jimmy Chan. All right, let's talk about LabWork 11. All right, LabWork 11. So the first problem starts off with a radical equation. So with radical equations, you want to get one of the radicals by itself if there was more than one. That's why it says get a radical by itself on one side. Then raise both sides by the index, solve, and check. Now, I'm not going to tell you which problems that I'm not going to tell you to check problems that you don't really need to check. So when I tell you that you should check these problems, you really should check these problems. So radical equations, you definitely want to check for sure. All right. So this way you know that any kind of radical equation, you ought to do that. So number one, I got to get the radical by itself. So the first thing I'm going to do is move that 6 over to the right side. So now I'm going to have a square root of 4x plus 8 equals to negative 6. Okay. Then what I'm going to do is to get rid of the radical, to get rid of the square root, I'm going to raise both sides by the index. The index, if it's not shown, is known to be a 2. So I'm squaring both sides because square root and squared are opposite operations of each other. So what's going to happen on the left side is that the square root is going to disappear because it cancels out with the squared. So I'm left with just the 4x plus 8 equaling to the 36. Because the negative 6 squared is negative 6 times negative 6, so it's positive 36. Then I solve for x. Subtract the 8 from both sides. I get 4x is equal to 28. And then divide by 4, I get x equals 7. Now, I can't box this answer yet until I check. So I'm going to go ahead and check if x equals 7 will work. So I have the square root of 4 times 7 plus 8. And see if that equals to negative 6. Well, what am I going to get over here on the left side? I want to have the square root of 28 plus 8. Is that equal to negative 6? Well, I'm going to have the square root of 36. Is that equal to negative 6? And the answer is no. Okay. Now, actually, I probably should have done it the other way. I probably should have done it this way instead, guys. Because this is the original equation. So the answer is no. Okay? Now, once I move this over to the other side, I should already know that there was no solution because I can't take a square root of any number and get a negative 6. So therefore, from that, once I move that 6 over, I should already know that there was no solution. So in this case, I have to reject this, that x equals 7, because now, well, only because it doesn't work out. So therefore, my answer is no solution, which is choice A. And there we go. All right, so that's number 1. On to number 2. Number 2, I have another radical equation, but again, if I have more than one equation or one radical, I want to get only one of them on one side and the other one on the other. Nice part about this is that they're already separated. So all I gotta do is raise both sides by the index. Since the index here is a 2, I square both sides. Well, what happens when I square both sides? Square root and squared are opposite operations. So I'm left with a 7x minus 3 is equal to x plus 6. Well, now I need to just get all the x's on one side and all the numbers on the other. So I want to subtract the x over and get 6x. I'm going to add the 3 over and get 9. So x is going to equal to 9 over 6, which really, x is equal to 3/2. Okay? Now, I still need to check this. Or say, I should still check this. So what I can do is go, okay, so I have a square root of 7 times 3/2 minus 3 is that equal to a 3/2 plus 6. Okay, so you're welcome to plug this into your calculator, and what you're going to get is that the square root of, let me see, sub e, 15/2 is going to equal to the square root of 15/2. So this is a check. So that is my answer, and that's going to be choice C. Okay. There we go. That's number 2. On to number 3. Number 3 is still a radical equation, except this is a cube root. So again, I want to get that radical by itself. So I got to add the 4 over to the other side. So that's going to equal to a positive 4. And typically cube roots, you don't really need to check. All right. So from there, I'm going to raise both sides to the 3rd power because the index is a 3. With that being said, the cube root and the cube are going to cancel each other out. So I'm left with just a 3x plus 2 is equal to 4 to the 3rd power, which is 64. Then just solve for x. So 3x is equal to a 62. Divide by 3, x is going to equal to 62 over 3. And again, with cube roots, you don't really have to, because I can take a cube root of a number and it could come out to be positive or negative. There's no really limitations on that. So that is going to be choice A. And there we go. All right, that's number 3. On to number 4. Another radical equation. This one's a little bit different because once we get everything to one side, the radical by itself, I should say, we're going to have a binomial on the other side. So again, I get the radical is by itself, so I'm going to raise both sides to the 2nd power. On the left side, the radical disappears. But the right side is x minus 1 squared, which means I gotta write x minus 1 out twice, which means I have to FOIL or double distribute that. So I'm gonna have 21 minus x equal to x squared minus x plus 1. So 21 minus x is equal to x squared minus 2x plus 1. I see a square term and an equal sign. So what does that tell me? That tells me that this is a quadratic equation, okay? So that means I gotta get everything to one side, so I gotta subtract that 21 over, I gotta add the x over. So I'm gonna have a 0 is equal to x squared minus x minus 20, okay? So I have a 0 side and a non-zero side, so I gotta factor that non-zero side, which is gonna be x minus 5 and x plus 4. So I'm going to have x equals 5 and x is equal to negative 4. All right? All right, because it's a square root, I do have to check this. So let me write this down for the quadratic. Okay, and then I have to check. So I need to check twice, right? The x equals 5 and the x equals negative 4. All right, so my original equation, I have the square root of 21 minus 5. Is that equal to 5 minus 1? And then I also have the square root of 21 minus a negative 4, and is that equal to a negative 4 minus 1? Okay, so with the 5, I have the square root of 16, is that equal to 4? Yes. Right? Over here, I have the square root of 25. Is that equal to negative 5? And that is a definite no. Okay? So I'm going to have to reject this one. And x equals 5 is my only answer. So that is going to be choice D. There you go. All right. So that is number 4. On to number 5. This is a right triangle and it's talking about its sides, right? So let's see here. It's a word problem, I know. So a balloon is secured to a rope that's staked to the ground. A breeze blows the balloon so that the rope is taut. So, rope, right? Rope is taut. The balloon is directly above the flagpole that's 50 feet from where the rope is staked down. So this is 50 here. And from where, find the altitude of the balloon if the rope is 100 feet. So the rope is 100 feet. The question is, how high is this? Okay. So remember, the Pythagorean Theorem says a squared plus b squared equals c squared. And the reason why the c squared is so Important is because C represents the hypotenuse, which is opposite of this right angle right here, okay? So it's opposite of that, and that's the hypotenuse, which is the 100 side. And then the other two are just legs. So if I apply the Pythagorean theorem, then I have x squared plus 50 squared is equal to 100 squared. So what I have here is that x squared is equal to 2,500, equaling to 10,000. Then I got some, this is not equal, this is still plus. Sorry about that. So I got to subtract that 2,500. So I got x squared is equal to 7,500, or 7,500. And then I have to, take the square root of both sides. Yes, you should be doing the plus and minus. However, for now, because we're talking about sides, we can really just focus on just the positive because we're talking about the distance of a side here. So I got x is equal to, now I have to break this down. All right, so let me break this down. 7,500. I know this is going to be 75 times 100. 75 is going to be 3 times 25. 100 is going to be 10 times 10. So I got the 3. I got the 5 times 5. I got the 2 times 5 and the 2 times 5. So with that being said, what do I have? I got two 2's. 2 times 2 times 3 times 5 times 5 times 5 times 5. Okay, so let me double check. Let me type that in the calculator. 2 times 2 times 3 times 5 times 5 times 5 times 5. That is equal to 7,500. Awesome. So I don't need this part anymore. All right. So if that's the case, my index is a 2. So I have a pair here. I have a pair here, and I have a pair here. There we go. So x is going to equal to, I got a pair of 2 that comes out, a pair of 5 that comes out, and another pair of 5 that comes out, leaving me on the inside just a 3. So 5 times 5 times 2 is equal to 50 square root of 3. And that is choice D. All right, so that's number 5. On to number 6. Oh, number 6. This looks like a binomial times a binomial, right? So here is my suggestion. I would tell you to write this out so that, before I even do that, I would tell you to do square root of 8 times this right here. Okay, so I would actually write out the double distribute here. Plus 2i times this. So I would literally write this out. It's easier to see, okay? So from there, you can then double distribute, and what you're gonna get is this. So I would draw lines to help you guys. So square root 8 times square root 8 is gonna give you an 8. Square root 8 times negative 2i is going to give you a negative 2i square root of 8. Then 2i times square root 8 is going to give you a positive 2i square root of 8. And then, go fuchsia here. Then 2i times a negative 2i is going to give you a negative 4i squared. Okay? So here's the thing. I squared is equal to negative 1. So really what I have here is 8. Now notice what happens to these two things right here. They cancel each other out, don't they? All right. So, which makes sense because if you look at the original, they're conjugates, meaning same terms, but one's addition, one's subtraction. All right. So those cancel out. So I really have 8 minus 4 times negative 1 because I squared is equal to negative 1, which would make this an 8. An 8 plus 4, which is equal to 12. Now, because it's 12 and it wants it in a plus bi form, okay, then this is going to be, I'll make this extend a little bit, a plus bi form. That means this is going to be a 12 plus 0 I, because there's no imaginary here, only the real part. So it would be 12 plus 0 I, and that is going to be choice C. Here we go. All right. So that's number 6. On to number 7. All right. So this, if you notice, has a square, right? And what does that mean? That means I have to write this out twice. So I gotta write it out twice, and I gotta FOIL or double distribute this, okay? So when I FOIL, I should get a 64 plus a 72i plus a 72i plus an 81i squared. Now don't forget, I squared is equal to negative 1, right? So really what do I have here is I got 64 minus 81 plus 72i plus 72i, okay? So let me see here, 64 minus 81. So I got negative 17 plus 144i. And that will be choice B. Boom. Close enough. All right, so that's number 7. Number 8, rationalize the denominator. So I got to get rid of the I out of the denominator. Doesn't like i's in the denominator because it is a radical and you can't have radicals in the denominator. Nice part about these is that with monomials, the 3 is allowed to be there, the I is not. So what I'm going to do is I'm just going to multiply 3i with I, because if I multiply by I squared is negative 1. So, and that will get rid of that I. So, But since I did it to the bottom, I have to do it to the top. So my top is going to be a 7i, but my bottom is going to be a negative 3. Because again, I squared is equal to negative 1. So my answer is actually going to be a negative 7i over 3. Now the question is, does it want it in a plus bi form? Which it does. So if it wants it in a plus bi form, that means I have, since there's no real part, because this is attached with the I, so the real part would be 0 minus 7 thirds I. Okay, so that is going to be choice C. Let me see how I'm going to do this here. Let me bring this all the way over here, and this is going to be choice C. There we go. That's 8. On to number 9. Ooh, rationalize the denominator, but this is a binomial. Oh boy, binomial. Okay, so first of all, I like my parentheses around binomials. So binomial is a little bit different. If I multiply by I, right, if I only multiply by I, this is gonna be 4i minus 3, which that means the I is still there, so that's no good. No good. No bueno. All right, so what I actually have to multiply by is the conjugate. So which is 4 minus 3i. Since I did it to the bottom, I have to do it to the top. Okay, so my top is going to be distributing. And since my bottom are conjugates, all I have to do is flip first and last. So when I distribute the top, I should get a 36 minus 27i over the bottom is going to be a 16 minus 9i squared. And I squared is a negative 1. So negative 1 times a negative 9 is going to be a positive 9. Excuse me. So this is going to be a 36 minus 27i all over 25. Okay. So with that being said, it wants an a plus bi form. So that means I got to split that 25 in the denominator. So I'm going to actually have a 36 over 25 minus 27 over 25i. Okay, so this is the a plus bi form, and that is going to be choice C. Boom. Boom. All right, so that's number 9. Let's look at number 10. Oh, the good old quadratic formula. All right, if you search on YouTube for quadratic formula songs, you're going to get a ton of them. Okay, so let's take a look. So here, this is in the standard form, which is ax squared plus bx plus c equals 0. You have to always get into standard form first. So with that being said, a is equal to 2, b is equal to 8, and my c is equal to 7. So I just plug it in. So x equals negative b. So that means negate b. So b is positive 8, negate it, negative b, 8. Plus or minus the square root of b squared, which is going to be 64, minus 4 times a times c all over 2 times a. There you go. So here's my suggestion. You should only plug in what's inside this radical. So just that 64 minus 4 times 2 times 7. So let's try that. 64 minus 4 times 2 times 7. Okay. So this is going to give me negative 8 plus or minus the square root of 8 all over 4. I can simplify 8 because 8 is what? Come on. It's 2 times 2 times 2. So that means I have a pair and with the leftover, right? So that means that pair of 2 would come out with a 2 left inside. So what I actually have here is that x is equal to negative 8 plus or minus 2 square root of 2 all over 4. But I'm not done. We're also going to have to talk about this so-called triangle method here. Let me see what I want to use. This looks nice. So for the 3 things that are outside the house, okay, and if something goes into all 3 of them, which 2 does, then you can reduce that fraction. So essentially, x is going to equal to negative, so 2 goes into all of them, right? So it would be negative 4 plus or minus square root of 2 all over 2. So that would be my answer right there. There we go. Which is choice C. And there we go. All right. Well, that is your lab work 11. If you have any questions, please let me know. All right. Talk to you later. See ya. Bye.